Hi, it's Rob. Welcome to the next video in the DevOps on AWS playlist where we'll look at CodePipeline. AWS CodePipeline is a continuous delivery service used for automating the software release process. If you watched the prior videos in the playlist on AWS Code Commit, Code Build, and Code Deploy, you'll recall this image, which shows where those services fit into the DevOps pipeline. However, until this point, we've interacted with those services individually in a manual process. In the upper left corner of this pipeline diagram, you'll notice the AWS CodePipeline icon. CodePipeline orchestrates the software delivery process in stages, such as build, test, and deploy. So this diagram is depicting the integration of code commit, code build, and code deploy into CodePipeline stages. And the benefit of using CodePipeline with these services is automation. Although manual approvals can be included at any stage in the pipeline, say for approving deployment to production after the final automated test stage. If you watched the prior video in the playlist, you'll recall we introduced an S3 bucket which stored the build artifact from code build, which was the input into code deploy. In this code pipeline diagram, we've added one more S3 bucket, which is used to store the source code pulled from code commit. So artifacts are stored in S3 at each phase of the pipeline and used for input into the next stage. Key to automating the stages in code pipeline are actions, which trigger the various stages in the pipeline, like committing source to code commit, or a successful build, test, or deploy phase, which will trigger the next stage in the pipeline. In this video, we'll see how to configure stages for source, build, test, approval, and deployment in CodePipeline by integrating code commit, code build, code deploy, and stage actions. So if you're ready, let's jump in and build our first AWS CodePipeline. To get started, I've configured an IAM user named CC Developer, granted the user administrator access, and configured the user on my local machine. I've also created HTTPS GET credentials for AWS Code Commit. Looking back at the code pipeline diagram, we'll recall that the first step in the pipeline occurs when the developer writes code and pushes it to code commit. So that means I'll need a code commit repo. And to create that, I'll jump into a terminal and execute an AWS code commit create repository command, passing it a repository name of CC demo app and a repository description of repo for CodePipeline demo. Now I'll copy the output and save it off so I have the clone URLs for later. And now if I execute an AWS code commit list repositories command, making sure to include my profile name, we'll see our repository listed. Now, in order to interact with the repository, I'll issue a git clone command, passing the clone URL I copied when we created the repo. Now it's prompting me for my username, which I saved when I created my git credentials for code commit, and then paste the password. And now we see I have my code commit repo cloned locally on my dev machine. Now, with our remote repo in place, let's jump into Visual Studio Code and take a look at the code itself. The application I'll be deploying is a simple Spring Boot app. When loaded in the browser on port 8080, displays the text Cumulus Cycles with the current version number. So looking at the code, I'll do a brief overview starting with the POM file, which is in the root of the project folder. As expected, there's a properties node and appropriate dependencies for the Spring Boot app, and a build node. Now, I won't go into detail in the implementation, as this isn't a tutorial on Spring Boot, but I'll just explain how the application's put together so you have an understanding of what you're deploying. Now, jumping into the source main folder and going into Java com Cumulus Cycles package, you'll see the demo app class. This is annotated with a Spring Boot application annotation and has the name of demo class and has an override for the configuration. Inside of the controller package folder, we see an app controller class annotated with the controller annotation. This has a private variable for data and a mapping of the root. So when the application is hit on the EC2 instance by specifying the IP address and the port 8080, which is what the application runs on, /demo app, this mapping will be invoked and the model will have the data added as an attribute and then return the index. The index is an HTML file in the resources templates folder, which simply has an H1 element and injects the value of data. And data comes from the application properties file specifying the data starting with cumulus cycles v1. And as we progress through the deployments, we'll change the version number and then validate the deployment in the browser. Now let's take a look at the buildspec.yaml file, which is also in the project's root. If you watch the code build video in this playlist, this file should look familiar to you. Here we're specifying a version and the phases. There's an install phase, which indicates a runtime version of Java Corretto 17, and then a build section with a command to run a Maven clean package. There's a simple echo in the post-build phase, and the deployment artifacts are files consisting of the war file in the target folder, the stop server shell script, the start server shell script, both of which are in the scripts folder, and the app spec YAML file. Now, taking a look at the app spec, which will look familiar to you if you watched the prior video in the playlist on code deploy, we're specifying the version and the operating system is Linux, and then in the files block, we're specifying a source for the demo app.war file, with its destination being the web apps folder in the Apache Tomcat installation. The app spec has two hooks, an application stop, which uses the stop server shell script in the scripts folder, and an application start, which uses the start server script. So let's jump into the scripts folder, and looking at the stop server shell script, we see it simply invokes the Apache Tomcat shutdown script, and the start server script invokes Tomcat's startup script. The file name codedeployuserdata.txt is a file containing the user data script we'll pass in when we provision our EC2 instances. The script does a sudo yum update, installs Ruby and wget, and then downloads and installs the CodeDeploy agent. Since this is a Java application we're deploying on Apache Tomcat, the script will also install Java and Tomcat. The EC2 trust policy.json file is an IAM policy which allows EC2 to perform the STS assume role action, and the CodeDeploy trust policy.json file allows CodeDeploy to execute the assume role action as well. Both of these files will be used when we provision the roles for our resources. Now, I know we went through the app spec and build spec files and the user data script as well as the trust policies kind of quickly, but if you'd like a more in-depth walkthrough of those files and their use, feel free to check out the code build and code deploy videos in this playlist. Now, let's push the code up to the remote code commit repo. Now I'll copy my code commit username and password. Then if we jump into the code commit console and go into our repo, we see our code has been pushed. All right, with the code sitting in the remote repo, we can move on and provision the infrastructure we'll need for our pipeline. First, as previously mentioned, we'll need an S3 bucket. Now, I know I've said that we'll be using 2 buckets in the pipeline, but we're actually going to create 1 bucket in which CodePipeline will create 2 folders. We'll see this a bit later on. But for now, let's jump into the terminal and create the bucket. So I'll execute the AWS S3 API create bucket command, passing it a bucket name of CC pipeline artifacts with today's date. Now I'll go ahead and add versioning to the bucket. And now if I run an AWS S3 API list buckets command, we'll see my bucket has been created. Okay, next I'll create two IAM roles, one for the EC2 code deploy role, passing the EC2 trust policy JSON file we looked at earlier. And as a reminder, this policy allows EC2 to perform the STS assume role action. And I'll attach the Amazon EC2 role for AWS code deploy policy to it. And then create an IAM role for code deploy, passing the code deploy trust policy we looked at earlier. And again, this policy allows code deploy to perform the STS assume role action. And I'll attach the AWS code deploy role policy to the role. All right, now we can move on and provision our EC2 instances, which the pipeline will deploy to. As in the last video in this playlist, I'll be provisioning the security groups and ingress rules, the EC2 instance profile, roles, and instances, along with some other resources, using the AWS CLI. I'm going to move a bit quickly through most of the provisioning, so if you'd like a more detailed walkthrough and you haven't watched the prior video in the playlist on code deploy, feel free to pause this video and go give that one a look. Okay, so the first step in provisioning the resources is to get the VPC ID. So I'll grab the ID and copy it off. Then I'll get a subnet ID. And I'll copy the subnet ID for US East 1A and copy that off. And then I'll create a security group and copy the group ID. Now I'll go ahead and create a security group ingress for SSH. Do the same for HTTP. And an ingress for TCP on port 8080, which is the port that our Java application will run on. And then I'll create the instance profile. Now I'll add the role to the profile and create an EC2 key pair. And then I'll run an AWS EC2 run instances command, passing it the image ID for an Amazon Linux 2 instance in US East 1. I'll indicate I'd like 2 instances of the server. The type will be a T2 micro. I'm passing the key name I just created, as well as the instance profile. I've added the security group and the subnet IDs, and the user data will come from the code deploy user data file we looked at previously, which, as you recall, will do a yum update, install Ruby and wget, and then install the code deploy agent. It'll also install Java and Tomcat. Now, if we jump over to the EC2 console, after a few minutes, we see our app servers up and running. So I'll select one of the servers and click connect, and then connect to the server using EC2 Instance Connect. Then I'll run a sudo service code deploy agent status command to check and see if the code deploy agent has been installed and is running. And we see the agent is up and running. Now, if you get an error message when you first try and execute this command, give it a little time for the service to be installed and started. Then let's just jump over and check the service on our other instance. And that looks good, so now we can move forward and provision our pipeline. The first thing I'm going to do is jump into the code build console and create a build project. I'll give it a name, and then for source, I'll leave the default of AWS code commit and select a repository. And for the branch, I'll select main. For the environment, I'll use a managed image of Amazon Linux 2 with a runtime of standard, and the image will be the latest version. I'll let code build create a new service role, indicate we'll use a build spec file, and then create the build project. Now I'll jump over to code deploy and create an application. I'll give it a name, and for the compute platform, I'll select EC2 on-prem and create the application. Now I'll create a deployment group. I'll give it a name, select the service role of code deploy role we created earlier, leave the default for an in-place deployment, and for the environment configuration, select Amazon EC2 instances. For the tag group, I'll select a key of name and a value of app server, and add a tag for environment, and select dev. And here we see we have two matching EC2 instances, which are the instances we previously deployed. And if we jump back and look at our EC2 run instances command for the tag specifications, we'll see we're passing tags, one with a key name and a value of app server, and the other with a key of environment and a value of dev. For the agent configuration, I'll select never because we installed the agent ourselves. For deployment settings, I'll use the code deploy default for all at once and deselect the load balancer and create the deployment group. Now with code build and code deploy configured, I'll jump into the CodePipeline console. Here I'll click create pipeline, give it a name, and allow it to create a service role. Under advanced settings, I'll select custom location and choose the S3 bucket we created earlier. And I'll leave the default for the AWS managed key. Click next. Under source provider, I'll select AWS code commit, select our repo and the main branch, and leave the defaults for CloudWatch events and CodePipeline default. Now I'll click next. And under the build provider, I'll select code build, select our build project, leave the default for a single build, and click next. For deploy, I'll select code deploy, select the application name and the deployment group, and click next. Scroll down and create the pipeline. Now we see the source stage of the pipeline is in progress, and it's now complete, and the build is in progress. And it looks like our build failed. So let's jump in to the view and code build and see if we can figure out what went wrong. Okay, so the failure was on download source with an access denied error message for primary source and source version in S3. So let's jump into build projects. And here we'll select our project. We'll look at the build details and scroll down, and we see the service role. So let's open the service role. And under permissions, I'm going to add a new permission. And for the demo, I'll select S3 full access. I'll add the permission. Now let's go back to CodePipeline and retry the build phase. So the build's in progress again. And after several minutes, the build is successful and it's moved on to the deploy stage. And the deploy has succeeded. So let's jump over to the EC2 console, select one of our instances and grab the IP, paste it in, add the port of 8080, and our demo app. And here we see our page content. Now let's do the same with the IP address of our other server. and that looks good as well. Now, let's jump into VS Code, and in the application properties, we'll change the data from cumulative cycles V1 to V2. Go back to the terminal, do a git add, a git commit, fix my typing, and a git push. Paste in my code commit username and password. And if we jump back over to CodePipeline, shortly we should see the source stage change from succeeded to in progress. And it happened very quickly. It's actually succeeded just now, and it's moved on to the build stage. Now the build has succeeded and the deployment is in progress. And with the deploy succeeded, if we jump into the browser tab for our first EC2 instance and refresh, we now see V2. And if we do the same with the other tab, we have an updated version here as well. Now, with the pipeline working properly, I just want to jump into S3, into our pipeline artifacts bucket. And if we select it, we'll go into the folder for the demo app pipeline, and we see two folders, a build artifacts folder and a source artifacts folder. These are the two folders that the pipeline created inside of our bucket to manage the artifacts from one stage to another. Okay, with our pipeline successfully executing from source to build to deploy, right now we're deploying to dev servers. What I'd like to do now is jump back into the terminal and provision 2 more EC2 instances for our prod servers. So here I'll run another AWS EC2 run instances command. Again, I'm passing the image ID with a count of 2. The instance type will again be T2 micro just for the demo. I'll pass the key name that I created earlier, the instance profile, the security group, and the subnet IDs. This time in the tag specifications, I'm still passing a key of name with a value of app server, but for the environment key, the value is prod instead of dev. And again, I'll be using the user data file, which we looked at earlier. All right, now while those two instances are spinning up, let's jump back into the code deploy console. And inside of my application, I currently have one deployment group for dev. Now I'll create another deployment group for prod. I'll use the same service role we used for dev. Again, we'll do an in-place deployment to EC2 instances. The name will still be the same, app server, and this time the environment will be prod. And it's telling me I have 4 unique instance matches, which shouldn't be the case. So let's jump in here and see the details of our EC2 instances. So I currently have 4 running EC2 instances. Let's check the one on the bottom. Go into tags, and this has a tag of dev. Now let's check the next one. This also has a tag of dev. And let's check the 2 we just created. This has an environment of prod. And this has an environment of prod. So we only have 2 EC2 instances with the environment of prod. So I am a little confused as to why we have 4 matched instances. But what I'm going to do is I'm going to remove the name tag for now. And this goes down to 2 unique instances as we expected. Again, I'll say never because we already installed the code build agent. We'll take the default for the deployment settings and uncheck the load balancer and create the deployment group. Now let's jump back into CodePipeline and edit the pipeline. So what I'd like to do here is add another stage, which will be production deployment. I'll add an action group to the stage, which will be deploy. The action provider will be code deploy. And the input artifact to the deployment will be the code build artifact, defined by the build stage. We'll select the application name and the deployment group for prod and click done. Now I'll save the pipeline. And we see our new prod deployment stage, which hasn't yet run. So I'll jump back into VS Code, change our version from 2 to 3, save the file, jump into the terminal. Do a git add. A git commit, and a git push. Okay, now with the code pushed back up to code commit, let's jump back into CodePipeline. And shortly, we see that the source stage has now succeeded and the build is in progress. Now the build was successful and it's moved on to the deploy stage for our dev servers. And the deploy to dev was successful, and now the prod deployment stage is in progress. And with the prod deployment complete, let's jump back into the EC2 console. We'll grab an IP address from one of our dev servers, jump into a browser tab, load the page, and we see version 3. Now let's go back to EC2 and grab an IP for one of our prod servers. This is prod. Jump into another browser tab, and we see our latest revision deployed to our prod servers as well. All right, so our pipeline is in pretty good shape. We can run a phase to grab the source. We can run a phase to do the build using code build, and we can deploy to our dev and prod servers using code deploy. But there's one more stage I'd like to add to this pipeline, and that's to insert a manual approval stage between the dev deployment and the prod deployment. So maybe a developer makes a code change and pushes it to code commit, which triggers the pipeline to start. It'll pull the source down, pass it over to code build to do the build, and then deploy the build package out to the dev server where someone can go and test it. And upon successful testing, they can come in and do a manual approval, which will take the package and deploy it to prod. So let's scroll up to the top of our pipeline. We'll edit. And then between the deploy to dev and the deploy to prod, we'll add a new stage. And we'll call it approval. I'll add the stage. Then add an action group. The action provider will be manual approval. And here I could specify an SNS topic and a URL for review, and perhaps this is a URL to the dev servers, and actually in a real environment it would be to a load balancer. And I'll go ahead and click done. Oh, and it looks like I need to fix the name. And now we have our manual approval stage. So I'll scroll to the top and save. And here's our manual approval, which didn't yet run. So one more time, let's jump into VS Code, change this to V4, jump into the terminal, do an add, commit, and push, and jump into the pipeline. Now the source phase is in progress. And that succeeded. And now the build stage is in progress. And that succeeded. And now the deploy to dev is in progress. And that succeeded, so it's moved on to the manual approval process, which is in pending status. So it's waiting for approval. I'll go ahead and click review and approve. And we see the manual approval process now has a status of approved. And the approval has succeeded, so the pipeline has moved on to our prod deployment, which is in progress. And now with the prod deployment succeeded, let's for the last time jump into the EC2 console, grab an IP address for one of our prod servers, jump back into a browser tab, and now we see the pages being served with version 4. So that concludes this video on automating our CI/CD pipeline using AWS CodePipeline. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more videos to the playlist, please consider subscribing to the channel. Thanks for watching.